today's experiment, we're going to be making thermite. And I want to show you this extremely exothermic reaction. This is the rig that we have set up here, and I'll go through the parts. We've got 2 clay flower pots filled with the thermite mixture. And then we have a bucket of sand to contain the liquid iron that's going to come as a result of this reaction. So let's look at the components for this reaction. It's actually a combination of 3 metals. I've got iron oxide, which is just rust, essentially. And then we have aluminum powder. The aluminum powder is just like the aluminum that makes up our aluminum cans or aluminum foil. It's just very finely ground into a powder. And the last is this strip of magnesium, and this actually is going to be the fuse for our reaction. And if you remember, magnesium is very reactive. We can actually light this metal on fire. This is what will get hot enough to get the other 2 to ignite. So let's look at the test setup. So like I said before, we have 2 clay flower pots there. There's a bucket of sand below. That will catch the molten iron that will come pouring out the bottom. And then the top, that's a combination of the iron oxide and the aluminum with our magnesium fuse. Before we light it, let's look at the chemistry that's going to be going on. So our reactions there at the top, Fe2O3, so iron oxide plus 2 aluminums yields aluminum oxide and 2 irons. Those iron are what's going to be the liquid iron, and then a tremendous amount of heat and light. In fact, the liquid or the melting point for iron is about 1,530 degrees Celsius, which comes out to about 2,800 degrees Fahrenheit. This whole reaction reaches around 2,200 degrees Celsius, which is about 4,000 degrees Fahrenheit. So when we say exothermic, releasing heat, this guy releases a lot of heat. It is also a single replacement reaction. The iron and the aluminum, if you notice, swap places. So a single replacement. We can also call it an oxidation reduction reaction or a redox reaction. That simply means a transfer electrons from one atom to another. Okay, I'm going to light the fuse using a torch. So the heat of the reaction was enough, I don't know if you can see in the video, that it cracked the terracotta pot, the outside one. If we look down in, it's still glowing now down in the center. And then we'll see if we can fish out some of the iron. You can see some of the gray blobs right there at top at the end of my tongs. That's the liquid iron. Well, not liquid anymore, but So there's some of the iron right there. I don't know how well you can see it. There. So this one is a do not try at home, guys. This one's for Mr. Bigelow only.